Hi, this is Stephen. I'm a physicsforum.com member, and physicsforum.com just added a 3D printing forum. And I'm not much on physics, but it's really a great resource for the prototype model building I like to do. This is an anaerobic biodigester model I just recently started working on. And I thought I'd share it with the group to see if we could spark up some conversation, whether it be for people already involved in 3D printing or those who want to know more about it. Uh, I think this just shows an example of the different things that you can incorporate into prototyping. There's some instrumentation. That's a pump and a temperature gauge. We've also got a water heater down below. There are some augers that's actually driven by a belt-driven system up on top. That is the output port, and you'll see there's actually a little check valve mounted in there. If we spin it around, you can also see the intake port. One of the things, I've actually built a 250,000 gallon version of an anaerobic digester, and one of the things I learned was that swept curves really work well with this type of system. The top, and I'm going to pull it out, and it actually clips in to keep the system anaerobic or without air. But right now you can pull it out and you can see the system on top. Now we're going to go ahead and look at a close-up still, and you can see a lot of the different types of systems you can create with 3D printing. There is some threaded fittings, left-handed and right-handed. You'll see that in the lower right-hand corner is a heater. This is a belt-driven system right here that drives the augers down below. The filaments that we're working on, this is actually a nylon that creates the drive and the belt drive. Some of the parts are in the PETG plastic and also polycarbonate. The yellow you see there is actually a neoprene, a specialized neoprene that works well with nylon, which is really hard to stick together, but it's a terrific material to print with. Has a lot of great features. Tallman makes the nylon, and 3M makes this specialized neoprene. You can purchase it on Amazon, but it is a specialized neoprene that I really like to work with. That's the stripped down version of the top without all the stuff mounted on top of it. So here again we're looking at the top that inserts down below. There's actually in the bottom of that acrylic tank is some mounting saddles, I call them, that allow the augers and some of the other systems to remain centered when they rotate. Okay, so now we're going to go ahead and look at the auger systems a little closer, I believe. And in the foreground is a heater and a pH probe and some of the pumping, but the augers are used to mix the manure or the food waste that creates the methane. It's actually a bacteria called methanogenesis that is created by allowing the material to break down. But again, for those that want to prototype or build very specifically targeted models that function, I would love to engage those folks on the forum. For those that are in the scientific community or the engineering community and would like to learn more about 3D printing and how that works in terms of approaching it from the point of view of a functional approach to it, not just trying to make cool stuff, but make things that actually work and that you actually design in advance to perform a certain function. for me, I need to understand much better the physics of how things work so that I can predict when I design how that design will perform. I also need to understand sometimes the principles of why things perform. Here's a clip, and there's a series of them, and there's actually a vulcanized rubber seal compound on each side of that, the bottom and the top, and those clips put it in tight. Here you go, you can see the vulcanized rubber. It's on the top and the bottom fitting, and the pressure clamps, also 3D printed, hold it down tight. You can see at the bottom there, those are the saddle fits that allow the turning to be completed on center. There's some shapes there that, from my experience, allow for a better functioning of working with manure and working with food waste in terms of having them flow easier. And with this clear tank, I can try out different mixing systems, different flow systems, different ways of introducing recirculation and temperature, and then apply that to real scale systems. One of the things that I know about prototyping and model making is that, of course, we're always dealing with variables, and with a small model, some of the variables are just microscopic. They don't even show up on a data SKU. Whereas when we recreate this system as a series of 4 concrete tanks that total 250,000 gallons of manure, of material, these smaller variables show up in very critical situations. So the modeling doesn't always, or doesn't ever, remove the hidden variables. But what it does do is allow you to observe and to see things that in 3 dimensions, and see how things interact. And when you run into problems just in geometry, this really works it out. But it also helps you organize a system. After this, I'm going to go ahead and show you a video I have of a parabolic mirror system that I built. I've actually got that with a narration ahead of time, so I'll just let that run. And I've also got some solar trackers that I've been working on. But really, what I want to do is just connect with the physicsforum.com guys and just talk about 3D modeling and what they would like to do in their engineering and science interests, and talk about 3D modeling. I'm 68 years old. I've been doing this since 1986. So this is a little experiment with a parabolic mirror, trying to achieve not only a temperature of boiling or 100 degrees Celsius, but maintain it with a circulated water system that would go through a condenser and a pump and be able to maintain that temperature, again being circulated. So this is entirely 3D printed. You can see down below there's a little copper tubing that is part of the condenser that we're going to use to try to experiment with measuring the temperatures. The system itself, the parabolic wings, are fairly short, so we're working with a system of reflected light that is probably under-engineered, yet we still have maintained a 92 degrees Celsius temperature here. There's a bidirectional switch and a motor to rotate the axis back and forth. You'll see a little small circulating pump. Again, all of the systems are 3D printed, including the union joints that are created to be able to disassemble the tubing a little bit easier. You can see, again, it's just a 1 RPM, rotations per minute motor, very slow. Here's a vertical tube is just for the filling of the system. Now watch this shadow here. Watch it move as it on the center of the parabolic mirror. As the axis begins to rotate, you'll see that it starts to center up, and you'll also notice that the tube itself above will start to glow as this comes right on target. So we didn't quite achieve our goal of boiling, but again, I think by lengthening the quote-unquote wings of the parabolic mirror some, and also by using these little cables you see in the foreground to adjust the twist or correct the twist to concentrate the light even more true to the line of the target copper, I believe we can achieve the boiling water easily. I've added on this little clip at the end of a bidirectional solar tracker. It works very well for systems like photovoltaics or solar electric, and for passive solar water heating, where you need a general aiming towards the sun to optimize those systems. However, the parabolic systems, I've finally conceded, need a very exact aiming to the sun to maximize the efficiency. And I feel like in this case, it's going to need a robotic actuator with a timing set to the rotation of that particular season time and solar declination.